Why baby animals start kicking before they can walk. Picture this. You buy a brand new high-end smartphone, you unbox it, boot it up, and the very first thing it does is download a military-grade antivirus software before the home screen even loads. That is exactly how nature builds a baby prey animal. If you click on a video of a newborn zebra or calf, you'll notice something deeply unsettling. The little guy is barely 5 minutes outside the womb. Its legs are shaking like absolute jelly. And yet it is already violently launching tactical, Olympic-level defensive kicks at anything that breathes. It's like they were born directly inside a martial arts movie, completely skipping the tutorial phase. Meanwhile, if you look at a human baby, we spend the first 2 years of our lives trying to figure out how our own thumbs work. A human baby can't run, can't find food, and can't even hold its own head up, looking less like a survival machine and more like a smartphone running on 1% battery with a loose, broken charging port. But out in the wild, a baby zebra has been alive for less time than it takes you to skip a YouTube ad, and it's already executing high-stakes maneuvers to dodge an apex predator, which feels fundamentally unfair. Imagine being born at 9 a.m. and getting hunted by a lion before lunch. No orientation, no onboarding, just straight into the competitive server. And this creates an insane biological mystery that most people completely look past. If a newborn animal's brain hasn't even finished installing the basic software to walk properly, how does its body already know the exact physics required to launch a perfectly aimed defensive kick? It didn't learn it. It didn't practice it. It just booted up with the file already downloaded. The cliché answer is predators. But that surface-level explanation doesn't go nearly deep enough. Because hidden inside that clumsy first kick is a ruthless, brilliant strategy about how evolution programs life. And as it turns out, nature doesn't care about teaching a baby how to live. It only cares about teaching it how not to die. Have you ever tried to gently pet a newborn calf, only to be welcomed with a lightning-fast, perfectly targeted kick straight to your shins? The calf can't even maintain its balance. Its front legs are crossing over each other, looking like a glitching video game character whose animations haven't fully loaded. Yet, the millisecond you step into its blind spot, those back legs fire off with lethal precision. In human terms, this makes zero sense. We require months of safe, cushioned environments just to master a basic crawl, and years before we can run without tripping over our own shadows. But prey animals arrive with a very specific, dark program already running in the background. Not walking. Not coordination. Pure, unadulterated defense. It's almost as if nature decided that delivering a blow was infinitely more important than receiving a hug. And evolution is mathematically correct to think this way. For a wild prey animal, the most dangerous day of its entire existence isn't old age, and it isn't a harsh winter. It is the exact day they are born. Once you look at the code, you see this exact blueprint across every grassland, forest, and desert on Earth. Before a newborn creature even registers what light or oxygen is, its muscles are already hardwired to fight back. But here is where things get genuinely weird. We like to think that learning requires a feedback loop. You try, you fail, your brain logs the error, and you adjust. The problem is, nature doesn't offer a free trial period. A newborn foal will attempt a defensive kick within hours of hitting the grass, not after watching its mother do it, not after a training arc. In some recorded cases, they attempt the kicking motion before they have even successfully stood up on all 4 legs for the first time. So who uploaded the file? For decades, science operated under the assumption that the brain arrives as a tabula rasa, a blank slate. The world provides the data, and survival depends on how fast you study for the test. Then, nature started showing us exceptions that completely broke the server. Take sea turtles. They hatch from eggs buried deep under the sand, entirely alone. Yet, the moment they break through the surface, they sprint directly toward an ocean they have never seen, perfectly reading a planetary magnetic field they don't even know exists. Or look at baby spiders, who hatch with zero parental guidance and immediately spin flawless, structurally complex geometric webs on their very first attempt. The deeper evolutionary biologists looked, the more terrifying the realization became. Animals aren't arriving empty-headed. They are arriving with ancient fragments of data pre-installed in their nervous systems. This isn't knowledge or memory in the human sense. It's legacy code. Evolution realized millions of years ago that certain lethal problems occur so consistently across generations that waiting for a baby to learn from experience is a guaranteed extinction event. If a single mistake in the first 10 minutes of life deletes your data from the server, natural selection stops relying on education. Instead of teaching the lesson after birth, nature builds the defense mechanism directly into the neural wiring before the animal even takes its first breath. That clumsy newborn kick isn't practice. It's an encrypted file of ancestral trauma and triumph, passed down by the ghosts of every ancestor that survived long enough to breed, handed directly to a creature that has been alive for less than an hour. But that introduces a massive psychological paradox. If evolution can pre-program behaviors, why prioritize a kick over basic balance? The answer has nothing to do with winning a fight. In fact, evolution rarely cares about winning. It only cares about maintaining data. When we see a baby zebra kick, we view it as a weapon. We imagine it trying to defeat a predator. But a baby zebra doesn't need to win a 1v1 match against a lioness. A newborn wildebeest doesn't need to overpower a pack of hyenas. The goal isn't victory. The goal is a system crash in the predator's brain called hesitation. In the wild, predators are not reckless monsters. They are hyper-calculating biological machines, constantly balancing risk against caloric reward. Every hunt drains their battery. Every single injury carries a potential death sentence. A minor scratch on a lion's eye or a tiny fracture in a cheetah's leg doesn't just hurt. It means they can no longer hunt, leading to starvation weeks later. Because of this, predators aren't looking for a glorious battle. They are looking for an absolute guarantee, an easy, risk-free meal. And this is where the evolutionary psychology gets fascinating. A newborn calf is weak, slow, and highly vulnerable. But the moment it fires off an unpredictable, chaotic kick, it completely shifts the predator's risk index. The kick doesn't say, "I can beat you." It says, "I might break your jaw or blind you before you manage to kill me. Am I really worth the gamble?" Field researchers studying hunting behavior have found that apex predators will instantly abort an ambush if the prey displays even a fraction of sudden, violent resistance. The moment the risk index spikes, the predator's brain glitches, hesitates, and reconsiders. That awkward newborn kick is a biological pop-up warning label designed to buy the baby exactly 3 extra seconds. And in the wild, 3 seconds is the exact margin between staying inside the herd or becoming a line item on a predator's menu. This reveals the ultimate truth about how nature designs life. Evolution doesn't try to build a perfect, flawless masterpiece on day one. It just wants to build a basic, functional prototype that can survive just long enough to upgrade its own systems later. The very first application nature downloads into a prey animal isn't walking, grazing, or exploring. It is a single, hard-coded command: stay alive. When humans think about childhood, we picture a sandbox mode, a safe zone protected by massive societal firewalls where you can make mistakes, drop your guard, and slowly figure out the world. Wild animals don't get a sandbox mode. They are dropped straight into the competitive, live server. Predators will not pause the game while a newborn figures out its center of gravity. Long before a baby animal ever encounters its first threat, its nervous system is already executing defensive solutions shaped by 1 billion ghost ancestors who face the exact same danger. Those first clumsy, chaotic kicks are not random muscle spasms. They are echoes traveling across millions of years of time. They are fragments of survival knowledge that existed long before the individual animal itself ever did. When you watch a newborn animal throw a wild, awkward kick and miss completely, it looks like a baby making a mistake. But in reality, you are watching legacy code expressing itself through a body that hasn't even dried yet. The baby doesn't know why it's kicking. It doesn't have to, because long before an animal ever learns how to live, nature has already taught its body how to keep the machine running.